Today we're solving the problem 29.33 for the final exam. In this problem we do have 4 parts and I solved each of them. So for the part A I got the answer, which is the magnitude of the current is 0.225 and the direction is clockwise. For the part B I got the magnitude of current is 0. For the part C the magnitude of current is also 0.225 and the direction of the current is counterclockwise. And for the part D, I sketched the graph, which I will explain later. So basically, we didn't explain how to solve each part in details. So basically, in part A, we have to find the magnitude and direction of the current that's going into the magnetic field. So to start with, we have to define the formula for the current, which is I equals EMF over R. And in this formula, EMF equals B multiplied by L multiplied by V. Therefore, we can define current as B multiplied by L multiplied by V over R. So in this problem, we do have already some information as V, which equals 3.0 meters per second. And we also have B, which is 1.25 T. So using this given information and formulas that we just defined, we can calculate the current, and it's going to be equal 1.25 multiplied by L, which we also have, which is 75 centimeters. And it's the same as 0.75 meters multiplied by 3.0. Let's do this real quick. And all of this is over 12.5, which is R. So in this we got 0.225 A, and this is the answer for part A. So basically, this is the magnitude of current that's going into the magnetic field. What about the direction? I would say that the magnetic flux increases because the magnetic field points out of the page. So according to Lenz's law, the direction of this particular current is going to be clockwise. So the direction is clockwise. Moving on to the part B, we have to find the total within the magnetic field. So basically, we need to find the magnitude of the current in total. So in this specific case, the magnetic flux is constant, so the rate is also constant. The rate is also 0, and this is why the magnitude of current is going to be 0. So this is the answer for part B. Moving to the part C, we have to find also the magnitude and direction of the current, but it's moving out of the field. So basically we can use the same formulas and the same given information from the problem. And I would say that substituting in the equation, we're gonna get the same answer for part C, which is 0.225A. So the magnitude of the current that's moving out of the field is also 0.225A. But the direction of this current is going to be different, I guess, because the magnitude flux decreases because the magnitude field points out of the page. So according to Lenz's law as well, the direction of this specific current is going to be counterclockwise. Okay, for the last part, we have to sketch a graph of the current in this circuit as a function of time and include the preceding three cases. Okay, to sketch it, we basically have to, first of all, sketch the axis. And it's gonna be like this. Okay, so we have to include all three cases that we just solved. So part A, B, C. Basically, we know that the answer for part A was 0.225A, and for part C, it was the same answer, but the direction was different. So we have to, we can put these two numbers right here. And right here, because the direction of the current from part C was counterclockwise, so it's going to be the negative number. Okay, so having these two numbers, oh, we also have to define the axis as well. This one is current A, and this one is time. So basically, sketching that, we have to just put the put it like this, because we have time A. So because it was from part A. Then that we found that the magnitude of the current from part B was 0. We just move it along of the x-axis, and it's gonna be time B. And in part C, we had the same answer as for part A, but it is negative because the direction is counterclockwise. So basically, we're gonna move down along the y-axis, and we can do this so we understand that it's for this answer. And basically, moving on, we have to just finish the line. And it's going to be time C. So basically, this is the sketch for the part D, which shows all three parts that we found in this problem. And basically, we have the answer for each of this problem. So for Um, let's just summarize it really quick. So for part A, we get the magnitude of the current moving into the page was 0.225 A, and the direction was clockwise. For part B, we get the magnitude of the current was 0 A. For part C, the magnitude of the current was 0.225 A as well, but the direction was counterclockwise. And for part D, we just sketched the graph which indicates all three parts we've done before. So this is the answer for the problem 29.33.